In this video, I will be discussing graphing absolute values, specifically inequalities. I do have another video on equations that you can go back and look at later. So in this first example, I have a less than or equal to sign, which is my inequality that is going to tell me that my graph, well, first off, if I'm looking at the actual what's following the inequality, I see an absolute value symbol. So that tells me that I'm about to graph an absolute value graph. So it's either going to look like a V that's facing upward with arrows on it, or a V that's facing downward. Those are my only two options for what we're working on in class. So the first thing I typically look for is my vertex. And that's going to be my H and my K, which I've discussed before in other videos. However, as I've told you before, what's inside of your absolute value, you want to try to set that equal to 0 in order to find your X portion or H. And so therefore, this is really going to be -1 instead of +1. Now my K, I just leave the sign as it is. In this case, it happens to be a +3, so that's what I'm going to leave it as. Now, the reason I personally like to use my vertex is because now I can figure out based off of my vertex and my slope is always what's right before my absolute value symbols. Once I figure that out, I know that an absolute value graph is symmetric, so it's pretty easy to graph it. So for my rise, that's going to be the 1. Rise means up or down, depending on the sign. And then run means left or right, again, depending on the sign. In this instance, 1 is going up, and then 4 is going to the right. Well, I can also do -1 over -4 is going to be the same thing. You'll see what I mean in a minute. So as far as my vertex is concerned, I'm going to go over to -1 and then up 3. Then I'm going to plot a point. And now based off of my slope, I can go up 1 and over to the right, 1, 2, 3, 4. And because an absolute value graph is symmetric, I can also go to the left. That's what I was mentioning a few minutes ago. So I can go up 1 and then over 1, 2, 3, 4. And I'm going to do the same thing just one more time. I don't really have to. This is enough, but I can go up 1, 1, 2, 3, 4. And on the other side, the same thing. I'm going up 1, I'm rising 1 and running 4. 1, 2, 3, 4. Now what I want to do is make sure that I am actually connecting my points, and it should look like a V. Hopefully my ruler will work today. All right, so I'm going to go as far as I can that way. And then I'm going to do the same on the other side. And at the ends of it, you want to make sure that you put your arrows, which indicates that your graph goes on forever. I did talk about domain range and other key characteristics in the other video. So again, go check that out if you wanted to know more about that. So my line, if I am trying to figure out what type of line I'm going to have, whether or not it's solid or dashed, is based off of my inequality. And because this inequality has that equal sign portion, that tells me I'm going to have a solid line. And as far as the shading goes, I'm looking at the inequality that's listed above that equal sign. Is it a less than or is it a greater than? If it's less than, that means I'm shading below my graph. So everything below my graph in this particular graph or example is going to be shaded. And now what I want to do is I want to check it. And you can use whichever points that you would like to use, but I just usually use my origin, and I also use my y-intercept just to make sure that I'm on the right track. So what I'm doing is for my origin, that's 0, 0. That means I'm going to replace my y with 0, and I'm going to replace my x with 0. And now I'm just going to simply solve to see whether or not this statement is true. So on this side, I have a 0. And on the other side, once I simplify in the absolute value, that's just going to come out as a +1. So I can just go ahead and put parentheses 1 plus 3. And if I multiply the 1 times the 1/4, I simply get 1/4 plus 3. And now I just want to simplify that even further. So 0. Now, this is really going to be, remember, I have to have a common denominator. So this is going to be 4 at the bottom, and then I have to multiply 4 times that 3, which is going to be 12. And so now I have 13 over 4. And if I were to actually simplify 13 over 4 as a decimal, that's going to be 3.25. So is 3.25 larger than 0? Yes, it is. So if it is true, that means that the origin should fall under the shaded region. And that means it's one of my solutions. This is my origin, 0, 0, and it is in the shaded region. So now I want to check my y-intercept. My y-intercept can be found by, I can really just go to my table. That's what I would actually do. Go to the calculator's table, and under x, I would look for 0, and then it will give you the value for y, because x has to be 0 when you're looking for your y-intercept. Or you can actually just solve it by substituting 0 in for your x value and just manually solve it. So now what I wanted to do is I want to replace my y with the 3.25, and I can keep my x as 0, just as I did right above. And let's see if this is true. So 3.25, is it less than or equal to, well, we just said that it was 3.25 once we simplified it. And in this case, because I have this equal to sign, then yes, it's true. And what this is telling me is the line type, whether or not it's going to be a solid line or dashed line. So we already know, based off of the graph, that it was a solid line. So therefore, I actually did that one correctly. Now, what I want to do is show you in the calculator how this would look. And later on, I'm going to have the steps. Later in the video, I'll have the steps listed out for you. So what you do is, the first thing you have to do is go to your apps button. And I've already done it. So here. You go to your apps, and then you go to number 7. So you can literally just type 7 in. And right now it's giving me the option to continue or quit. So I want to continue. But you won't normally have that option. It'll say press any key. So that's what you would do. So I've already changed it, and I'll show you in the next example how to type this information in. So this is the graph that we're currently looking at example 1. So once I press it, this is what it looks like, which is what I just graphed. So what I wanted to do is show you, so let's go back to my vertex. I said that the vertex is -1 and 3. So I'm going to go and verify in my table. So second graph, and then I want to look down where it says -1. And yes, it is -1 and 3. So I know that this is in fact my graph. I could check more points as well just to make sure I'm on the right track. And you'll notice, looking at that graph, it was solid and it was below, a solid line below. But what if they actually already gave me a graph and I'm asked to write an inequality? So the first thing that I'm looking at, again, is I want to try to find that vertex. That's very helpful. So my vertex is where the two lines come together to form like either the peak of the graph or like the valley of the graph. So my vertex here, I can see, is going to be 2 and then 6. So the points 2 and 6. From that, I want to try to find my slope. My slope should be, okay, I'm going to go down 1, 2. So that's my rise portion. I went down, so I have to have a negative sign with it. And then I'm going to run 1, 2, 3 until I hit a point. So that's how I can tell. And I want to do that more than once to make sure that I am actually doing this right. I forgot to, there we go. So -2 over 3 is going to be my slope. And like I said, again, you could do that the other way as well. So 1, 2, and then go over 1, 2, 3, 1, 2, 1, 2, 3. And you're going to keep hitting the points if that is in fact your slope. So once I find my slope, all I have to do is determine what type of inequality I'm using. So I know this is y, and because it's a dashed line, I'm not going to have a greater than or equal to or a less than or equal to. It's just going to either be greater than if the shaded part is above, or it's going to be less than if the shaded part is below. And since this is above, then it's simply greater than. So my slope is what comes after that. So negative 2/3. And then my absolute value. Well, in order for me to have a 2 for my x, that means I'm going to have an opposite sign. So x is going to be -2, because again, this represents what would have to go in there to make this entire expression 0, the x minus 2 part. And then my k portion is just going to keep its sign, and it's +6. So this is what I believe to be my inequality for this graph that's shown. Then we're asked to describe the transformations. Well, the transformations are going to be similar to other transformations we've done. So this negative sign, that tells me that I'm going to have a reflection, so a vertical reflection over the x-axis. And then next to that is that 2/3. Well, since it's less than 1, it's a vertical shrink or compression, however you want to write it, by a factor of 2/3. And then here, this tells me horizontally, I'm going to shift a certain way. So horizontally, I'm shifting to the right by 2. So 2 units. And again, this is helpful. If I look at my vertex, whatever that number is, that's what I'm using. So since it's a +2 is to the right on the graph. So I know I'm going to the right. And then lastly, I have the k value, which tells me whether or not I'm going up or down. So it's based off of the sign. Here I'm going up. So vertical shift, or you can say translation, up 6 units. So I have 4 things happening with this particular graph. So go back to what the original graph should look like. The original graph is something like this. What did I do? I flipped it, or I reflected over the x-axis. I moved over 1, 2 to the right, and then I moved up 1, 2, 3, 4, 5, 6. So if you can see what the original parent function looked like, that will help you tremendously in determining your transformations. All right, let's move on to the next portion of this. So I'm asked to determine whether or not the points that are listed are part of my solution set. Well, if it's a solid line, that means all of the points that are on that solid line are included and they're considered a solution. If it's in the shaded area, that means it's part of the solution. If it does not fit any of those 2 criteria that I just said, then the answer will be no. So for instance, -8, -2 would be here. It's not in the shaded area, and there's not a solid line on the graph. It's dashed. So we would say no. As far as -7 and 0, that would be here. And because it's on a dashed line, it too is no. If that was a solid line, then it would be yes. 6 and 5 falls in the shaded area. So therefore, this actually would be a part of my solution set. Yes. So these are my steps. I'm just going to leave there for just a minute, and then I'm going to go back and show you how to actually put this in the calculator. You can always just go back and pause that and copy it down. So I want to verify that I did example 2 correctly. So I'm going to go back to my calculator. It's already in the correct mode here. So I'm just going to clear out what's here. Now, with this particular calculator on screen, I actually have to highlight it this way, but the one that I actually have in my hand, I use the steps. It's going to populate down here. It's going to have some buttons here, and you're going to have to select alpha and then one of these buttons in order to get your inequality. but that's not the case on this particular calculator. So once this is highlighted, I want to hit enter, and then I can change the color if I wanted to. So, you know, I can just arrow over and see what colors that they have. We'll try that. And then I can go down and it's going to give me an option to change. And I said that I believe that it should have been greater than. Let me just go back and double check. Yes, I said that y should be greater than. And it's telling me that it is going to be shaded above because it's greater than, and it's going to be a dashed line because it does not have the equal sign to it. So in order to keep going, I just hit enter and then okay. Arrow over one more time and then type in what I believe the problem should be. And I thought it was -2/3. And to get to your absolute value, you would press math. Where it says num, you want to go over. It's already selected as absolute value. Hit enter, type in x, and I said -2, and arrow over, and I said +6. This is what I said the graph should be. So if I hit the graph, oops, what did I do wrong? Let's go back here and make sure that I know what I did, I think. All right, did I press this? I did not. I don't know why. That's weird. But yes, make sure you press this. Maybe I pressed that. I don't know why I would have done that. But so you see the difference? It will give you an error. I'm glad that happened. So this is what it should look like. And if I go back, this is what it looks like. Now, I want to verify that that's true. I said that I think the vertex should be 2 and 6. So I'm going to go to my table, which is second graph. And where it's 2, it does say 6. So I know that I did that correctly. If I want to get rid of this because it's causing other programs not to work, then what I need to do is hit apps again, go back to number 7, and then tell it to quit. And so now it'll get rid of the it'll get rid of the shading, and it'll just show you the regular absolute value. Okay. I hope this video was helpful. I would appreciate it if you give me a thumbs up and subscribe. Have an awesome one.